In our last lecture, we had a chance to start talking about measures of spread, which rather than focusing on measures of central tendency like mean, median, and mode, where we're just looking at like the central value of the data, we've started to talk about how consistent the data is or how spread out it is. And we did that by initially looking at standard deviation. And now let's move on and talk about Z-scores. So what is a Z-score? A Z-score is the number of standard deviations that a datum is from the mean. That this is calculated by dividing the deviation of a datum by the standard deviation. There are two forms of the equation that we're going to use. There is the popular Z-score, and once again, that just means the Z-score for populations. So Z equals X, that's our data point, minus mu, so that's our mean value. And we've kind of worked with this or something similar when we talked about standard deviation, and then divided by the standard deviation. So how many standard deviations am I away from the mean? And similarly for a sample, same idea, Z equals X, that's our data value, minus X bar, so that is our mean for a sample, and divided by our, actually that should be S because we're dealing with a sample here, so let's fix that up right away. Divided by S, so divided by our standard deviation. Values below the mean or below the average have negative Z-scores. So how far to the left have I gone? Values above the mean have positive Z-scores. So how far to the right have I gone on my graph? And values equal to the mean have a Z-score of 0. So how far from the center, or how far from the mean are you if you're on the mean? Well, 0. It's like if I'm looking at a regular graph, x, y, and my x value is 0, no matter what my y value is, how far from the x value, or how far from the y-axis am I? 0. So any value, x, comma, 0. To get a feel for this, let's work through an example. Our example says, the marks on the math portion of the SAT are normally distributed with a mean of 462 and a standard deviation of 100. Brooke Shields scored a 608. What is the corresponding Z-score? So how many standard deviations from the mean did she score? And we're going to add a second question to this as well. What percent of students did she score higher than? So kind of working with a different version of the note here. So let's start with A. What is the corresponding Z-score? Let's see what we know. Let's see what we need to find. Let's find the formula that's going to help us to calculate this, and we'll go from there. So first of all, we're going to let X represent the SAT score. So X is equal to 608. And we want to find Z. And what is our formula for finding Z? Let's plug in our values and find out. I think we can assume we're looking at the population because SAT scores are measured against population in this case. So we're going to have Z equals X minus mu over sigma. And do we know any other values? We know the 462 is our mean, so we should identify that as well. Mu is 462. And we know the standard deviation is 100, so sigma equals 100. Now that we know our values, let's plug them in and let's solve for Z and find our Z-score. Z equals, so X is our data point we're looking at, and we're looking at Brooke Shields' score of 608, minus the mean, which we're told is 462, divided by the standard deviation, which we're told is 100. And if we go ahead and calculate that, we're going to get a Z-score of 1.46. So we've answered the question. Therefore, let's write it on the bottom here. Therefore, Brooke Shields' score, so her score on the SAT, was 1.46 standard deviations above the mean. So it's positive. We know that we're moving to the right. And so she scored 1.46 standard deviations above the average value. Let's visualize that as well. And so if we have, we're going to have our x here. And I'm also going to add a second axis. It's going to be our z. And let's take a look at our possible scores. And we're going to have 162, 262, 362, 462, 562, 662, 762. What did she score? She scored a 608, so we'll make a mark approximately at that point. Like, we're just sketching by hand to get a visual feel for it. It doesn't need to be exact. So 608 is going to be around here. And the mean was 462. All right. So we're basically looking at, I'm going to pause for a moment. You can probably hear the sirens in the background. All right, so let's start from the center here. The mean is 462, and the standard deviation is 100. So every time I move 100 to the left, and that's why I chose those numbers for my x-axis. This is z-score -1, so I've moved 1 standard deviation to the left, and 2 standard deviations to the left, 3 standard deviations to the left, so my z-score is -1, -2, 0. Any values on the mean have a z-score of 0, z-score of 1, and 2, and 3. So we said her score is 1.46, her z-score is 1.46. So that means that it's going to be right here. So her score is, if we measure the width of that, so to speak, 1.46 standard deviations above the average. We're going to add a follow-up question as well. Let's do that now. For question B, we're going to consider what percent of students did she score higher than? We're going to revisit the idea of normal and what the area under the curve means in a little bit. But for now, we're just going to kind of go ahead and use that idea, and then we'll explain it more later. So the idea here is that the area under this curve represents 100% of the people who have taken the test. And we want to know what percent of students did she score higher than. Basically, we want to know what is the area under the curve to the left of her score. I'm going to actually switch my color here for a moment. And you might think, area under the curve, we solve that using calculus. Well, we don't actually have to do calculus here. Instead, we're going to use the z-score to determine the probability, or what percent of students, I should say, did she score higher than. And so we want to know what is the probability of a score being greater than 6. Sorry, of a score being less than 608. And so we've just seen that 608 means we're finding the probability that our z-score is less than 1.46. That's the value we just found. And how are we going to find that? Well, let's take a look. This is where we're going to be learning something new here. I'll switch my camera view here in a moment, but the tool we're going to use is a z-table or a z-score table. And what we're going to do is, using the z-score that we already found, we're going to look up the area under our curve or the probability of the item we're looking at. So our z-score is 1.46, and basically we have a table of values, and we're going to look up 1.46, and the table is going to give us the area under the curve or the probability. So this is located in your textbook if you have it on pages 606 and 607. Some of you might have noticed on your formula sheets that we've used previously for tests and quizzes that we also have this table provided, and that's for answering questions like this. So I'm going to switch my view now. Let's take a look at a digital copy of the table, and let's use it to find our answer here. So what is the probability that Z is less than 1.46? So I'm just using a random website here that happens to have those values. And we'll also notice, just like in your book, that the table is split into two halves. So I have the values to the left of the mean. So this is the negative z-score table. So we noticed all our z-scores here are negative. I can actually zoom in a little bit for you. So these are the negative values. And then we have another table for the positive z-score, or the positive z table. And so our value that we're working with here is positive 1.46. So I'm going to look on my table, and I'm looking at 1.46. So I'm going to go down. Hopefully you can see my mouse here. We're going to go down. So Z is 1.4, but I need 1.46. So that means I'm going to move across, because these are my hundredths values here. So these values down the left side go up to the 10th. Go away, powered by Weeble. And we're going to find our hundredth as well. So 1.46, so I'm going to go down, positive 1.4, 1.46. So my value here is going to be 0.9279. So let's go carry that value over to our note. So we're going to write that this is equal to, just running out of room, so we'll jog over here, 0.9279, and we'll indicate this is from our table. And what does that value mean? Well, let's interpret that and write our conclusion right now. Therefore, Brooke Shields scored higher than, so we're finding this is the area under the curve that was represented here. So how much, if that's a certain chunk of the population, what is the size of the chunk that she scored higher than? Brooke Shields scored higher than 92.79 of SAT test takers. And so this is where the z-score becomes useful, because it allows us to interpret using our z-score table if we have a normal distribution, and to say something about how much better did we score than other people, or what percentage of the population are we scoring greater than or less than. Once you're done this section, there are a number of practice questions here. These are the same practice questions we did when we worked with standard deviation, but now you can actually do the z-score questions as well. So please go ahead and work on those now if you have not done so already, or if you have, go back and make sure you've done the z-score component as well. Also, feel free to talk and discuss with your groups and compare answers and ask if you're struggling with anything.